Today's first presentation is a research update with Amy Beise and Andy Ayesh. Amy will present the first part of the presentation. Amy Beise is the team lead for research and pavement design within the Materials and Research Division. She oversees the operation of the research program, concrete and bituminous thickness recommendations, falling weight deflectometer data collection, and pavement profiling. Amy currently is organizing the initiatives of the Hot Mix Asphalt Advancement Group. Andy Ayesh will present the second part of the presentation. He is the research and pavement design engineer with the DOT. Before joining the DOT, he worked for several years as a project engineer and enjoys applying his construction background to relevant and practical research projects. He's a professional engineer and a graduate of NDSU with a bachelor's degree in civil engineering. And with that, I will turn it over to Amy.
Thank you, John. Yes, welcome to the last week of the Construction Project Development Conference. So Andy and myself, we really wanted to take this time and opportunity to do a short research update and talk about something that we probably don't spend enough time talking about. We need to take a little more time and talk about bases. Bases are something we pay attention to them when the roads are getting built, and then they get covered up. We never see them again, or we hope to never see them again. So they're kind of this forgotten middle layer, but they're really important. It's really what's underneath your pavement that you can't see that plays a huge role into the performance. And we want to talk about something that's actually really relevant to what's happening every year around this time. Every year in the spring, our roads get really, really weak. And so why this happens, I'd explain, is it being the 3 W's of weak pavements in spring. So you got winter, you got water, and you got wicking. So winter, I guess, doesn't need a whole lot of explanation. If you've spent any amount of time in this state, it's where it gets ridiculously cold for extended periods of time. But water is a big deal when it comes to pavement performance in the springtime. Water is what influences the stiffness of the material underneath the pavement. And it really changes everything in terms of how these sublayers perform and how they support our pavements. And last we got wicking. Wicking is where we get even more water coming up into these sublayers. It gets sucked up from below and up to the surface. So I'll explain that a little bit more. We see issues with these weak pavements in the springtime, but it's actually caused by a series of events that happen all year round. So in the summertime, there's always some level of natural presence of water in your base and your native soil beneath our pavements. Comes from precipitation. There's just a natural tendency for certain types of soils to hang on to a little bit of moisture. But what happens when fall comes around, the temperatures significantly cool off. And when these temperatures cool off, we start to lose a lot of heat through our pavements. And what this triggers is it's called a capillary rise, or it wicks water up from the water table up into our sublayers of our pavement structure. So 2 of the W's that happen for the weak soils, they actually happen in the fall. You got your water and your wicking. And this wicking action, it happens in all types of soils, but it's exceptionally bad in silty soils. Silty soils are kind of like a suction. They just bring it all up to the top. So what happens then, winter comes on. So this layer of moisture that's in our sublayers, it freezes. It forms what we call an ice lens. And this is where we start to see frost heaving action in our pavements. It's kind of a fun fact that the elevations of our pavements, they go up about 2 inches every year in the winter from this frost heaving, maybe even 3 or 4 in some of these areas that have really, really silty soils. But winter, despite it seeming like it lasts forever, it doesn't last forever. Eventually the temperatures increase, and there's still this frozen layer there, even though the temperatures are increasing, but we get this top-down warming. So all of that moisture, snow, precipitation that accumulated over the winter, it starts infiltrating down through the pavements, and there's still this frozen layer there. So the problem is it's got nowhere to go. It's just kind of stuck there. And this is where we see the issues with the really, really weak pavements during this time of year that we're in. And so you're probably wondering, well, how much damage can this actually cause? And the reality is it can cause quite a bit of damage. Our roads are really, really vulnerable to damage when these sublayers are saturated. This excess moisture, it can't drain. It gets down to this frozen layer and it's got nowhere to go. But eventually that frozen layer, it thaws out and moisture kind of finds its way out of the pavement section, and then that stiffness and strength of our subgrades is recovered. But during this little window of time where this phenomenon is happening, we got to protect our roadways from this excessive damage. And so what DOTs do is they applied seasonal load restrictions. Just looking at this picture here, the damage that this causes, it's not cosmetic damage. It's actually really serious structural failure to pavements. So what you're seeing here, it's actually not the pavement itself that failed. It's the supporting sublayers underneath lost so much stiffness and strength. Those are what failed. And then it propagates up through the pavement through bottom-up fatigue cracking. So the broken up pavement, it really is an effect and not a cause. So here I've got another good picture for you. There's a lot of good things to discuss on this picture. Same thing. This is not cosmetic damage. This is not normal wear and tear. This is serious fatigue damage. We lost our structure and our pavement here. You also notice how the cracks are a lot darker. That's really indicating that there's a lot of water underneath this pavement. But what happens is that because our support layers lose so much stiffness and support when all this excess moisture is present, it really impacts pavement's ability to handle heavy axle loading. So say during this time you have this like super big, heavy, overloaded truck, and it comes through this area when the sublayers are really weak. Let's take a look at those wheel tracks and where all the distresses are. It's really telling. So you have this really heavy load, but there's really nothing underneath that load to support it. And so that's where you see these distresses propagating, like I said, from the bottom up. So once again, not normal wear and tear. We always want to build our roads from the bottom up, but we always want to fix them only from the top down. Well, the damage that's caused by this time of year, it's almost always fatigue, structural failure, bottom up. It's not your economical top-down maintenance fix. So pretty much we got to be able to understand this phenomenon that's happening so we can properly time the onset and offset of these load restrictions. And we've got a few tools that help us do that. First tool we've got is called a falling weight deflectometer. So all of these green squares are our falling weight deflectometer testing sites. And so we run this piece of equipment all over these testing sites, and it measures stiffness and deflection. When you drop this weight, the more it deflects, the less stiff the pavement is. And so as we're continually testing these sites, we're looking for that rebound in stiffness. So just a big thanks to Nate and TJ in our section. They've really been keeping this operation going. It's a pretty big operation, and it actually takes us about 2 full weeks to test all of these green sites that you see. So that's one method we have. Another method we have, all these circles are our frost probes. So what frost probes do is they measure temperatures at different depths. So this particular one I circled here, you're seeing that top-down thawing, but you still have an indicator that there's still a frozen layer underneath. So the FWD, the falling weight deflectometer, and the frost probes, they're good tools, but this is really where there's a really big opportunity and need for research. We need to understand when our roadways are in this really weakened state so that we can protect them and still keep the traveling public moving. Keep those load restrictions limited to the smallest window that we actually can. And this is where I want to spotlight one of our multi-state pooled fund research efforts we're involved in. This is a big thanks to the maintenance division to get this into their research program. And what this does is you know, the concept of soils being weak in the spring, it's not universal to North Dakota. You know, multiple states with freeze-thaw issues have this same issue. So all these states in orange, they pooled their money together to work on implementation of road weather programs and essentially operationalize the use of weather data. So when you think of the W's of weak pavements, you got your winter, you got your water, you got your wicking. Well, weather really plays a pretty big role into all of those things. So the Aurora Pooled Fund, they studied some of our thawing models, and the objective of that study was to provide an understanding of the reliability, benefits, costs and risks of alternative approaches to predicting the start and end of spring load restrictions. So this is something that I think maybe a lot of people don't realize. North Dakota, we're actually a geographically big enough state that the whole state doesn't all thaw out at one time. So the needs for imposing and taking off load restrictions are going to be different in different areas at different times. Typically, the state, it'll start thawing out in the southwest corner, and then it moves in a diagonal direction up into the northeast corner. And so these spring thaw weather models, they help us understand how that thawing is actually occurring and gives us better data and better information. The first model we've got access to, it's called the Mndot Model, and this model helps us predict the onset of when spring load restrictions maybe should go into effect based on this weather modeling. Now this is an open source. Anyone with this URL can go ahead and access this data from this model. Then we've got the freeze tracks model. It's a similar weather model to the Mndot model, but it predicts both onset and offset of load restrictions. And this one isn't an open source. This one's actually proprietarily owned. We have access to it within the DOT, and we have access to the data that comes out of it. So these spring thaw models, the Mndot model, the freeze tracks model, how they work. You know, the point of this, I don't want to, dive too deep into the weeds for how they work, but actually really just show you what they do and how user-friendly they are. But essentially, in a nutshell, how they work is they are based on cumulative freeze indices and cumulative thaw indices. So we're gauging how hard something freezes for how long. And then in reverse, how do you take that freeze out? So the cumulative thaw index is what we're really interested in when we're looking at when the pavements are in this really weak condition. So it's kind of your average daily temperature swing minus a reference temperature. And the two models calculate that reference temperature a little bit differently. The freeze tracks model just uses a straight up 29 degrees, whereas the Mndot model is constantly adjusting that reference temperature based on the sun angle. So let's take a look at what this year looked like on the Mndot model. So here is the Mndot model, 2021 data. And what it recommends is that when you get to a cumulative thawing index of about 25, or the orange area, orange and yellow area on this scale. And it looks like you have a long-term forecast of about 3 days of things trending in an upward direction. That would be probably a good time to start looking at imposing load restrictions. So we'll just play this model right here. So you can see that in late February, it's kind of showing the early onset of thawing down in the southwest. Early March, the thawing becomes more aggressive and then starts to head diagonally up into the northeast corner of the state. By March 9th, it's showing that we're kind of in this critical thaw area in the whole area of the state. So then there's the freeze tracks model. This model, it still works on cumulative freeze and thaw indices, but it also models recommendations for no restrictions, imposing restrictions, and lifting restrictions based on these. So on this freeze tracks model, or sorry, on the Mndot model, it kind of showed everything was really critically thawed out by, the 8th or 9th of March. And so let's take a look at how this freeze tracks model looked. It's also showing to impose those restrictions in pink. By about the end of March, we're looking at restrictions on the whole state, and then it's moving into recovery in early April in the southwest corner. So that indicates maybe it's a good time to lift those restrictions. So our load restriction orders, they actually go on in phases as well. So our first set of orders went on March 9th, and this was everything south of 94 and west of 281. That was our first set of load restriction orders. Second set of load restriction orders was everything south of US 2. The whole state was under load restrictions with the March 19th order, which held in effect till April 6th, when things start to recover in the southwest and they were pulled south of 94 and west of the river. So this is kind of just a side-by-side, everything in the same time mode of how all those things kind of track together, how those different models and data track together. So I'll just go ahead and play that. You see we've got the Mndot model giving us an idea of thawing when it's happening in late February. And then in early March, we see that more aggressive thawing happening. You know, the freeze tracks model now is saying, hey, let's put on load restrictions, which DOT follows suit. And then mid to late March, we're looking at load restrictions in the whole state until early April, late March. That recovery is starting to show in the southwest, and our load restrictions were kind of following suit and pulled there. So pretty neat stuff. A lot of data is coming out of some of these research projects. They're big multi-state pooled efforts, and definitely a lot of good information that helps a lot of people around the DOT. So I will end there with my portion of this presentation, and I'm going to pass it over to Andy.